Good morning, dear students. So today I take legendres equation. So legendres equation means what? So it is a type of differential equation. Okay, so here it is defined as the differential equation equation 1 minus x square d square y by dx square minus 2x dy by dx plus n into n plus 1 into y equal to 0. Call this equation as 1 is called legendres equation. Is called legendres equation. So this type of differential equation 1 minus x square d square over dx square minus 2x dy by dx plus n into n plus 1 into y equal to 0. So this type of differential equation is called as legendres equation. Okay. So now we solve this type of differential equation. Here n is a real number. Where n is a real number, and this importance of this equation is very important in applied mathematics, particularly in solving boundary value problems involving spherical configurations. So here n is a real number. Now we solve this equation. Let y is equal to summation of k is equal to 0 to infinity ak x to the power m minus k be the solution. Okay, so now we substitute this in this equation 1. Okay, so to substitute this in this equation, so we need to obtain d square y by dx square and dy by dx. Okay, so let us obtain those derivative first. So differentiating 2 times. So first, when we differentiate first time, we get dy by dx equal to this is summation k is equal to 0 to infinity as it is. Then differentiation of this is ak is constant, so m minus k ak x to the power m minus k minus 1. Okay, so differentiating this ak is constant, this is of the form x raised to n, so n into x raised to n minus 1, this is dy by dx. Next, differentiating again d square y by d square is equal to summation from k is equal to 0 to infinity. Now this is m minus k into m minus k minus 1. Okay, ak is constant, x to the power m minus k minus 2. Now substituting all these, y dy by dx and d square y by dx square in equation 1. So then we get 1 minus x square summation from k is equal to 0 to infinity m minus k into m minus k minus 1 ak x to the power m minus k minus 2, then minus 2x summation from k is equal to 0 to infinity, then m minus k ak x to the power m minus k minus 1, then plus n into n plus 1 into summation from k is equal to 0 to infinity y, so it is x ak x to the power m minus k equal to 0. Okay. So or simplifying we get summation from k is equal to 0 to infinity m minus k into m minus k minus 1 ak x to the power m minus k minus 2 minus summation from k is equal to 0 to infinity, then m minus k into m minus k minus 1 plus 2 into m minus k minus, I will write here, minus n into n plus 1, then close the bracket, into ak x to the power m minus k equal to 0. Okay, or this also can be written as summation from k is equal to 0 to infinity m minus k into m minus k minus 1, then ak x to the power m minus k minus 2, then minus summation from k is equal to 0 to infinity m minus k whole square minus n square, then plus m minus k minus n, okay, then close the bracket, this is n, close the bracket, x to the power m minus k equal to 0. Or this also can be written as summation from k is equal to 0 to infinity m minus k minus 1 ak x to the power m minus k minus 2 minus summation from k is equal to 0 to infinity, close the bracket, m minus k minus n into m minus k plus n, k plus n plus 1. Plus 1 into bracket x to the ak x to the power m minus k equal to 0. So in this case, this can be written as m minus k whole square minus n square. Now this is of the form a square minus b square. So a square minus b square can be written as a minus b into a plus b. So m minus k minus n into m minus k plus n, right? So after writing in this, then we take m minus k minus n common, and in bracket here m minus k plus n is left, then this plus 1. Okay, so then this gives, after this equating to 0, equating to 0, the coefficient of highest power of x, highest power of x, highest power of x. So that is, the highest power of x is here. What is the highest power of x in this? So when we multiply all the things and we multiply, then we obtain x to the power m is the highest power of x, highest power of x, that is x to the power m, x to the power m. Okay, so then we get m minus n into m plus n plus 1 a naught equal to 0, okay, equal to 0. Then which means that a naught cannot be equal to 0, which implies m minus n is equal to 0, or m plus n plus 1 is equal to 0, which implies m is equal to n, or m is equal to minus of n plus 1, minus of n plus 1. Okay, now similarly, equating to 0, the coefficient of the next lower power of x, that is x to the power m minus 1, equating the coefficient of x to the power m minus 1 to 0. Okay, so then we get m plus n into m minus n minus 1 into a1 equal to 0, or a1 is equal to 0, because since m plus n cannot be equal to 0 and m minus n minus 1 also cannot be equal to 0. So because it is given that m is equal to n and m is equal to minus of n plus 1. So using this 2, so we said that m plus n cannot be equal to 0 and m minus n minus 1 cannot be equal to 0. So only possibility is what? a1 is equal to 0. a1 is equal to 0. So thus we obtain a1 value. a1 is equal to 0. Next is equating the coefficient of x to the power m minus k to 0. Okay, so then we obtain m minus of k minus 2 into m minus of k minus 2 minus 1 ak minus 2 minus and minus m minus k minus n into m minus k plus n plus 1 ak equal to 0. So from this we calculate ak m minus k plus 2 into m minus k plus 1 divided by n minus m plus k into n plus m minus k plus 1 ak minus 2. Now since a1 is equal to 0, so therefore so when you substitute k is equal to 2 here or 3 here, when you substitute k is equal to 3, so you will get a3 is equal to this into, if you substitute k is equal to 3, then this gives 3 minus 2 1 a1. Now as a1 is equal to 0, so therefore a3 is also 0. So when a3 is 0, similarly a5, when k is substituted as 5, and this becomes 5 minus 2 3. So a3 is already 0, so therefore a5 also becomes 0. So therefore all a3, a5, a7, okay, are odd terms, and so on, all are equal to 0. Next, when m is equal to n, then this gives, which implies ak is equal to minus of, put m is equal to n here, which gives n minus k plus 2, n minus k plus 1 divided by this n minus, when m is equal to n, so n minus n get cancelled, this gives k into bracket, when m is equal to n, this is 2n minus k, then plus 1, so this is ak minus 2. Okay, so after this put k is equal to 246 and so on. We get a2 is equal to minus n into n minus 1 divided by 2 into 2n minus 1 a0. Then a4 is equal to minus of n minus 2 into n minus 3 divided by 4 into 2n minus 3 a2. Okay, so now substituting this value of a2 here, which gives n into n minus 1 into n minus 2 into n minus 3 divided by 2 4 into 2n minus 1 2n minus 3 a0. Okay, so therefore substituting all these, in substituting all these, we get y1 is equal to, so this is the first solution, y1 is equal to a naught into bracket x raised to n minus n into n minus 1 divided by 2 into 2n minus 1 into x raised to n minus 2 plus second we substitute n into n minus 1 into n minus 2 into n minus 3 divided by 2 into 4 into 2n minus 1 2n minus 3 into x raised to n minus 4 dash dash dash. So this is for m is equal to n. This is for m is equal to n. So we get one solution, that is y1. So all this we have to substitute in the assumed solution. So what we assume, that y is equal to summation from k is equal to 0 to infinity ak x to the power m minus k. So there we substitute all these values. Next, put m is equal to minus of n plus 1 again in the solution we get. So we get ak is equal to n plus k minus 1 into n plus k whole divided by k into 2n plus k plus 1 ak minus 2. Now put k is equal to 2, 4, 6 and so on. We get a2 is equal to n plus 1 n plus 2 divided by 2 into 2n plus 3 a naught. Then a4 is equal to n plus 3 into n plus 4 divided by 4 into 2n plus 5 a2. So which implies substituting this value of a2 here. So which implies a4 is equal to n plus 1 n plus 2 n plus 3 into n plus 4 all divided by 2, 4 into 2n plus 3 2n plus 5 into a naught, etc. We get a2, a4, a6 and so on. So therefore substituting all these a2, a4 in solution, we get the second solution, that is y2 is equal to a naught into x to the power minus n minus 1 plus n plus 1 into n plus 2 divided by 2 into 2n plus 3 x to the power minus n minus 3 plus n plus 1 n plus 2 n plus 3 n plus 4 divided by 2 into 4 into 2n plus 3 2n plus 5 into x to the power minus n minus 5. Okay, minus n minus 5. So like that we get the solution. dash dash dash. So where n is a positive integer, and a0 is equal to 1, 3, 5 dash dash into 2n minus 1 divided by n factorial. N factorial. Okay, n factorial. So this is a first solution. This is a first solution. So it is denoted by. This is denoted by. So this is a first solution. Okay, then this is the second solution. Okay, so first solution can also be written as P1 of x. Okay, so here this solution, first solution, it also be written as P1 of x, and similarly this is the second solution. This is written as P2 of x. P2 of x. Okay, the first solution, the first solution is written as Pn of x. Pn of x. So this is the first solution. So this is Pn of x. Pn of x. And the second solution is written as Qn of x. So this is Qn of x. Qn of x. Okay. So now substituting this a0 in both the equations. Then we get, substituting a0, then Pn of x is equal to, so 1, 3, 5 dash 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 2n minus 1 divided by n factorial, then x raised to n minus n into n minus 1 divided by 2 into 2n minus 1 x to the power n minus 2, then plus n into n minus 1 into n minus 2 n minus 3 divided by 2 into 4 into 2n minus 1 2n minus 3 2n minus 3 x to the power n minus 4 and so on. This is called as legendres function of first kind. Legendres function of first kind. Okay, so whereas Qn of x is equal to n factorial divided by 1 into 3 into 5 dash 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 2n plus 1 into bracket x to the power minus n plus 1 plus x to the power minus n minus 1 minus n minus 1 plus n plus 1 into n plus 2 divided by 2 into 2n plus 3 x to the power minus n minus 3, then plus n plus 1 into n plus 2, n plus 3, n plus 4 whole divided by 2 into 4 into 2n plus 3, 2n plus 5 into x to the power minus n minus 5 dash 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 is called is called as legendres function of second kind. Legendres function of second kind. Okay, so these are the two important formula: legendres function of first kind and legendres function of second kind. So in the examination, they may ask either any one of these two. So the question is like this: derive the equation of legendres function of first kind, or derive the equations of legendres function of second kind. Okay, so this is for 5 marks. So now, after obtaining this, hence solution to the solution of legendres equation is given by y is equal to c1 plus into pn of x plus c2 into kn of x. So where c1 and c2 are arbitrary constants, where c1 and c2 are arbitrary constants. So with this I conclude this class and continue in the next class. Thank you.